Hey, welcome. So today we're going to dive right into the language of geometry and trigonometry. Before you can tackle the really cool, complex stuff, you've got to have the basics down cold. And that all starts with how we classify angles.
So let's start with a really simple question. How do you describe a turn? Is a corner sharp? Is it wide? To get precise about it, we need a system. And for that, believe it or not, we can thank the ancient Babylonians. They're the ones who decided to split a full circle into 360 degrees. Probably because 360 is just an awesome number to work with. You can divide it by so many things, 2, 3, 4, 5, 6, you name it, which makes dealing with fractions a whole lot easier. It's that same elegant system we're using today.
So if you want to speak this language fluently, the good news is you really only need to know 5 key vocabulary words. These 5 classifications, they're the absolute bedrock that pretty much all of trigonometry is built on.
Okay, so think of this table as our roadmap for the next few minutes. You've got the name, its degree range, and a quick description. But don't worry about memorizing this all at once, okay? We're going to walk through each one step by step. First up, we have the acute angle. Just think of a sharp corner. Anything that's bigger than 0 degrees but hasn't quite opened up to a perfect 90-degree corner is acute. Yeah, it's small, it's sharp. You could even say it's an acute angle. A little cheesy, I know, but hey, it helps you remember.
All right, next up is the right angle. And this is one you've probably seen a million times. It's that perfect L shape, exactly 90 degrees. But here's a super important pro tip. See that little square symbol right in the corner? That's not just for decoration. In the world of math, that's the universal sign for a perfect 90-degree angle. If you see that square, you know exactly what you're dealing with.
Now, what happens if you take that perfect L shape and start opening it up wider? Well, then you've got yourself an obtuse angle. Basically, it's anything bigger than 90, but not quite a flat line yet. Just think open or wide, that's obtuse. So what happens when it does open up all the way? When its two sides are pointing in exactly opposite directions? Well, that's a straight angle. It's a perfectly flat line, and it measures exactly 180 degrees. Makes sense, right? It's exactly half of a full 360-degree circle.
Okay, now for the one that sometimes trips people up a bit, the reflex angle. The best way to think about it is like a door that swings open past the point of being a flat line with the wall. It's bending backward on itself. That's a reflex angle. It's the long way round, always more than 180 degrees, but not quite a full circle.
Okay, we've got the definitions down. That's the theory. Now let's get practical and actually put these ideas to work. We'll start with something simple, just using our eyes.
All right, so let's say you see an angle like this out in the wild, but you don't have a protractor on you. How can you figure out what it is? Your first move should always be to compare it to what you know. Just picture a perfect 90-degree L shape right on top of it. You can see right away our angle here is definitely smaller. It's tucked inside that 90-degree corner. And since we know it's less than 90,
well, that means it has to be an acute angle. See? Simple as that. Just being able to eyeball it like this is a really great first skill to have.
Okay, so eyeballing is great, but what if you're just given a number? Let's say 215 degrees. All we have to do is run it through our list of definitions. Is it between 0 and 90? Nope. Is it 90 exactly? No. Between 90 and 180? Still no. Ah, but is it greater than 180 and less than 360? Yes! Bingo! We found its home.
And since 215 degrees falls right into that bucket, the one for angles bigger than 180, our answer is a reflex angle. See how it works? Once you know the rules for each category, it's really just a matching game.
So you might be thinking, okay, I get it, but why does this actually matter? Well, the truth is, these classifications are everywhere in the real world. Let's look at a couple of quick examples, and then we'll tackle a super common mistake that you'll want to avoid. Ever wonder how a car turns so smoothly? The inside and outside wheels don't actually turn at the same angle. It's not that simple. Engineers use a bunch of really specific, acute angles to make sure your tires grip the road instead of slipping. Or think about architecture. The angle of a roof, its pitch, is often an obtuse angle. That specific angle is a huge deal. It determines whether heavy snow will slide right off in the winter, or how cheaply you can build it in a place where it never snows.
Okay, lean in for this one, because this is probably the #1 mistake I see students make. It's so tempting to look at a 270-degree rotation and think it's the same as a negative 90-degree turn. And hey, they end up pointing in the same direction, right? But here's the crucial difference. Angle classification is all about the journey, not the destination. A reflex angle is always defined as a positive rotation that went the long way around. It's about the path you took to get there. So 270 degrees is a reflex angle, period.
All right, you ready to level up? Let's take what we know about angles and mix in a little bit of algebra. This is where things start to get really interesting and really powerful.
So, here's the challenge. We're told that this expression, 5x minus 10, represents an obtuse angle. We need to find the possible values for x. First things first, what do we know about an obtuse angle? We know it has to be bigger than 90 degrees but smaller than 180. That's our rule. So we can literally take our expression and stick it right in the middle of that rule. 90 is less than 5x minus 10, which is less than 180. Now it's just an algebra puzzle. To get x by itself, we first add 10 to every single part of the inequality. Then we divide everything by 5.
And boom, there's our answer. For that expression to be an obtuse angle, x has to be some value between 20 and 38. What we just did shows how these simple definitions become seriously powerful tools for solving real problems. This is exactly the kind of math an engineer would use to set the safety limits for a robotic arms movement.
So why did we spend all this time just naming angles? It all boils down to this, and this is so important for what's coming next in your trig journey. Being able to look at an angle, any angle, and instantly know its type, and eventually its reference angle, that is, without a doubt, the single most critical skill you need. If you can master this fundamental step, you're building a rock-solid foundation for absolutely everything that comes next in trigonometry. Get this right, and you're well on your way.